The data below yields a least squares regression line of y hat equal 55.402 minus 1.531x, where x is tug and y is the Berg score. It can be shown that if you look at the standard error of the slope, you'll get 0.215. What we want to do is find out if there's some statistically significant relationship between these variables, tug and Berg score, in the population. A way to find out if you have a statistically significant relationship in the entire population based on this sample of 16 observations is to test for the population slope. And we want to find out if it would be 0. If the population slope is 0, that means that there's no relationship between the two variables in the population. So our null hypothesis is going to be that our population slope, which we denote as a beta sub 1, is equal to 0. We reserve b sub 1 for our sample slope. Now our alternative hypothesis can have one of three choices: a greater than, a less than, or a not equal to. And that's going to be determined on what you're asked to find out. If you're asked for a positive relationship or a negative relationship in the population, you could use a greater than or a less than. Here we're just asked if there's some relationship, and so we're not given any directionality, so we'll just test if the slope is something other than 0. The test statistic here is equal to the slope from the sample, b1, over the standard error of that slope, our s sub b1. Now, both of these quantities, if you aren't given them, can be lengthy to find by hand. There's a long process, but in this case, we're given both of these quantities, so we can just plug them in. So we get negative 1.531 divided by 0.215, and so we get a t-test statistic of negative 7.12. The degrees of freedom for these test statistics is n minus 2, where n is the number of data pairs. We have 16 pairs, so we get a degrees of freedom of 14. We want to go into our t-table and look for the value 7.12. We can just look at the positive of that in row 14. And so when we go look in our t-table, we find that 7.12 is going to be off of our chart. So as I scroll through here, we'll see that our biggest value that we actually have is 4.14. So 7.12 is greater than 4.14, meaning the tail area beyond 7.12 is going to be smaller than the tail area here, so less than 0.005. So our tail area is less than 0.005. which is going to specify that our p-value is less than that quantity. But because we're doing a not equal to, we want to multiply by 2. So we get that our p-value here is less than 0.001. So we have a small p-value, which is going to lead us to reject our null hypothesis. And what that means is that we have significant evidence that there is some linear relationship between tug and Berg score in the population. What we're really determining here when we look at our alternative hypothesis is that our population slope is non-zero. So if you have a non-zero slope, you are saying that there is some relationship between your variables.